Hello, everyone. Thank you for attending today's webinar titled Top 10 Ways to Improve Your Powder Coatings Operation, brought to you by Products Finishing and presented by Vitracoat. I'm your moderator, Scott Francis, editor of Products Finishing. Today's presentation will last approximately 45 minutes, followed by a question and answer session. If you have a question, you can type it at any time during the webinar in the Q&A section of the chat. There is a handout as well, so make sure to check that tab. The webinar is being recorded and when complete will be made available to you via email from Products Finishing. Our presenter today is Steve Houston, Vice President and Business Director for Vitracoat. He has more than 35 years experience managing sales organizations, technical support teams, and research and development groups involved with industrial coatings. His career includes stints with DuPont Coatings and Color Technologies, RPM's powder division, and he has served as the executive director for the Powder Coatings Institute. Steve, I'll hand it over to you.
Thank you, Scott. I appreciate it very much. Well, thanks a lot for joining. I'm going to go through a number of slides, and I just want to kind of give you a snapshot real quick about who Vitracoat is, the company that I'm representing, and Product Finishing has allowed us to be a part of this great webinar. Vitracoat's been around since 1948, which is, believe it or not, even before I was born, a few years. And we've been in the industrial coatings business since then. We've been in powder coating since 1989, and fortunately have grown to become the largest independent powder supplier to the Western Hemisphere. To give you an idea of our capabilities, we've got manufacturing locations in Mexico, South America, United States, where I'm at right now, Elkhart, Indiana. And we also have an innovation research center in Houston, Texas. So we're committed to this powder coating world, and we wanted to be a part of webinars like this because we want to expand the use of powder. We want to talk about and educate how you use powder and how you're efficient and can become more efficient with powder coating technology. So without further ado, I'll tell you a little bit about what we're going to do today. I'm not sure of any of your capabilities or experience levels. So I'm going to start from the beginning, and I'm going to really give you just a few slides on what powder coating is. This seminar is for anyone. It's for anyone that has been an experienced powder coater or one that's brand new to powder coating. But powder coating is, unlike liquid, it does not have the vehicle or the solvent that allows liquid coatings to be sprayed. It's 100% solids. All the other composition of the coating itself are similar. We have resin, we have pigments, we have additives, we have things that give us the appearance and sometimes the physical characteristics of the product. But we're propelled by air, and the powder is sprayed in the dry form. That powder coating is applied to a surface, and then when it's experienced heat, whether that's radiant or convection heat, it'll melt and flow into a continuous film. All of the different compositions and in terms of performance, powder coatings can be extremely durable, high corrosion resistance, and can have a variety of different aesthetic looks. So powder coating today represents arguably about 15 to 20% of the industrial coatings world, and continues to grow in terms of that space, because as we bring in new technologies, the powder coating world and substrates that we apply to grows as well. So powder coating today, I'm going to talk about the top 10. Let me tell you a little bit about where I came up with this 10. I started with just a list, and I said, look, I've only got an hour to talk, so how many can I squeeze into an hour? And 10 was kind of that magic number. But unfortunately, I wrote about 30 down. So I spoke with some of my colleagues in the industry, and I said, look, this is my mission. I'm going to do a session. I'm going to cover the top 10 things you consider to work to optimize your powder coating operation. And I'm going to do it for persons that are new to powder coatings or long-term veterans. And I just want to have 10. So what would they be? So a lot of my colleagues that I respect and really have worked with through the years, we selected these 10. So by no means are they the only things you can do, but they do give you a really good snapshot. And from our experience, the things that are most overlooked or mismanaged or just not done at all, or maybe in some cases done improperly. So it'll start with some fundamental things, and then it'll kind of move gradually into some more specific things with relationship to powder coating operations. So let me just kind of walk through it. First, I want to tell you that I'm going to change the name of my session right now. The new name of my session is going to be called Come On, Man. And the reason I call it that is because throughout this experience that you're going to have in the next 45 to 50 minutes, I'm going to highlight some things, and I want you to kind of think about where you are in your operation. And I may ask you questions. I'm not asking you to audibly tell me your answer, but just mentally think about it. And I want you to think about, are we doing this right? Are we doing it wrong? And I'm going to kind of expose some of those things throughout the next 45 minutes or so. So when I say, come on, man, that means that this is an area that you really got to think about and be self-aware as to what you're doing. Okay. So let's get into it. Managing film build. I'm going through 10, and this is the first one. And one might say, well, yeah, man, I manage film build. I think many of you may be surprised at how many organizations that spray powder today do not have the simple tools to manage their film build. And that's just step one. Managing film build is important for a number of reasons. But let me tell you why I think it's most important. Thicker film build is not better, and thinner film build is not cheaper. And what I mean by that is that if we're putting it on too thick, meaning outside the parameters of the technical data sheet, then we're not getting a more protective film. We're getting more on the part, for sure, but there's not benefits in terms of physical characteristics. As a matter of fact, those physical characteristics can deteriorate. If I'm too thick, I'll typically lose impact resistance. I'll lose flexibility. If I'm spraying materials that are textures in particular, I'm going to change the appearance of that product. And even smooth products, as I get thicker, my orange peel has a tendency to increase. So thicker is not better. Thicker sounds like it protects better, but not necessarily gives you a better protective coating because you lose some characteristics. So thicker is not better. Thinner is not cheaper. Well, it might be cheaper in applied cost, but what you lose in your protection is going to hurt your product in the long run. As an example, if I have 500 hours of salt spray at 2 to 3 mils, well, at 1.5 mils or 1 mil, I'm going to lose much of that protection because I don't have that barrier of coating on top of my part. So film build management is important for a number of reasons. It's important because if you can start measuring it, then you can manage it. And you really need to know, am I within the parameters of this product? And then your next product may have different film build parameters. Am I coating these parts within the parameters of that product? Film build management can be a cost improvement, but it absolutely is going to impact your quality. And I suggest that you really kind of dig deep into how you're doing film build management today. This is an illustration of a part. Probably not yours, but it's a part. It's an electrical enclosure. And as I look at that part, you might say, well, my particular product that I'm spraying with that part gives me a recommended film build of 2 to 3.5 mils. Okay, that's great. But do I have to put 3.5 mils on every surface area of that part? I would say look at your part and come up with what is important in terms of visual characteristics and protective characteristics. So every part you have may have a drawing or at least a picture of it. And what I'm suggesting to you is as you go through and consider your film build management, look at not only how you're managing and measuring film build, I should say, but where you want that coating to be. As an example, what's on the screen is a print of a box, an electrical box. And as I look at that box in the top right-hand corner, you'll notice that I've added some letters. The A means that that's an A surface. And an A surface is going to be more visible. It's going to have more exposure to the elements. And so I want to make sure that I'm at the upper end of that spec to get the most protection. Still within the spec, but I want to be at the upper end of that spec. So I might be 2.5 to 3.5 there. On the inside, The B area, I might be 2 to 3. And then on the C side, I may not even need to be at that minimum for the TDS. I might want to be at 1.5 to 2 because that's going to mount up against a wall, and I really don't need much protection back there. So I'd highly encourage you, especially if you're in a manufacturing process and you're making the same product or similar product day in and day out, look at it and design A, B, and C surfaces, and then define what you want your coating parameters to be in terms of thickness on those surfaces, because they should vary, and they can vary depending on the product itself. There are different ways to measure film. There are a lot of manufacturers out there. I'm putting a few up here. I've got Alcometer, Positester, DeFelsco. There are others out there. I'm not promoting one over the other. I'm just telling you that if you don't own a film gauge, if you don't have one, then come on, man. Are you kidding me? If someone asks me, I got $1,000 to spend or $1,500 to spend, what do I do to start my quality control department? My first answer is buy a film gauge. It'll tell you so much information as you start to measure that film build. Am I in spec? Am I out of spec? And how do I control it? Not only can it be, as I said earlier, a cost savings, but absolutely an impact to quality. So what this is showing you is I also think you should log your film build. This is a crude illustration of what that might look like, but in the far column to the left, I've got a part description. Maybe it's a number or a written description, obviously the date. If it's a job that I'm working on, if I'm a custom coder or it's a particular project, I can add that on my list. It's a simple spreadsheet. It can be done electronically. Many of the film gauges will actually collect the data, and you can download them into a spreadsheet. And you're collecting the information specific to those products. And I've highlighted them. So red is out of spec. Yellow is right on the cusp. If I've got a 2 to 3.5 mil range and I'm running 2, I'm right there. And the green is below spec. Green doesn't mean good. It's just another color to illustrate that, hey, I'm too low on this one. In this particular case, the spec is 2 to 3.5. And as I mentioned earlier, I'd like to encourage you to also look at A, B, and C surfaces where that may change. So not only are you going to collect the data, but in this particular illustration, you also want to test the same area all the time. If Joe's evaluating film build or Susie, they know exactly where to evaluate film build on that part. And you do it in multiple locations, but be consistent that you do it in the same location every time, because that way you're actually getting some good systematic approach to film build collection. All right, man, I beat that up enough. Also, correct powder selection. So there are a lot of graphs, and in the PCI handbook, it tells you where to use epoxy. I think it was generally taken from this particular evaluation of which chemistries work in which area. But I'm digging a little deeper. I want you to select the right product for your application, because the product selection is going to impact performance, appearance, application, and cost. I'm going to fly through some of these, and you can get a copy of this presentation if you want to. And after, at the end of it, I'll send you you'll see my email address. I'll be more than happy to share it with you. So I'm going to fly through some of these and just give you the narrative. But this is one of the main areas we see powder applicators doing it wrong, by selecting the wrong product for their application. This image is a UV index from around the world. And when you think about UV index, what really the sunlight and the UV rays on powder coatings, or any coating for that matter, sometimes we look and we say, well, okay, in those environments, because my product's going to be put outdoors, I'm going to use super durable. And I just want to guard against that. Not that super durables aren't good. This illustration shows you that super durables can outperform standard durables by 2 to 3 times in some cases. If you think about the American Architectural Manufacturers Association, AMA 2603 is a standard durable, and you have to have a super durable to meet AMA 2604. So it's a good way to go, but the super durable is just a word. It's not a brand. It's not a specification. It doesn't meet a criteria. It's only one component of that coating. So when you're selecting the right product for your application, you really need to link it to a specification, because I can give you a super durable coating, and if I don't look at the pigment selection, or worse yet, I give you the wrong pigment selection, it's not going to perform well. If I use the wrong extender in a super durable with a super durable resin, if I use the wrong deglossing agent, ratio of ingredients, super durable is one component. You want to link what your product has to perform like to a specific specification. I mentioned a minute ago, American Architectural Manufacturers Association, AMA, they have specifications for 1 year, 5 year, and 10-year performance. And that's a good place to start if you're looking for something that needs to extend durability of your part through UV, through being exposed to UV. But there's other things. Are you spraying a casting, which is illustrated on the right? Castings are porous. They can have interior porosities, porosity, they can have blind porosity, through porosity. Do I need a product that gives me some outgassing resistance? Do I have a product that has very sharp edges where I've got to keep in mind good edge coverage? Am I running high line speeds and I've got to really impact transfer efficiency? Is the geometry such that I need a product that can penetrate Faraday's better? So the list can go on and on. This is all about making sure you select the right product for your application. If you're using a metallic, you can get metallic by extruding the metallic, by blending the metallic, and by bonding the metallic. And bonded technology is when we're encapsulating that metallic ingredient with the resin. So it goes through a pressure and blending process. And bonding can give you some very, very good benefit in terms of application over those other two approaches. So keep that in mind as you're selecting your product. And the last one here is, hey, man, if you're buying the cheapest product, come on, man. Seriously? Cheapest product isn't always the lowest cost for applied cost. These 3 beakers have 3 different products in them. Obviously, it's a green. All of these have 3 different prices, but each one of those beakers are weigh exactly the same. The difference is specific gravity. And obviously, the one on the right is going to give me more mileage because I get more powder. It has a lower specific gravity, lower density, lower weight per particle than the other 2. So price per pound is only one element. When you're selecting the right product, make sure you're selecting the right one in terms of applied cost. And one element of that can be specific gravity. The use of a primer, I think, is underrated. I think it's underrated because you're going to hear me say things like atmospheric condition. If you're making a product that's going typically or all the time into the attic of a house, atmospheric conditions to you aren't that critical. But where is your part going to be used? Where is your end product going to be placed in service? What atmospheric condition is it going to be exposed to? Is it going to be close to a beach environment? High salt, high moisture? Is it going to be in a snowy environment? Cold? Obviously, salt in these cases can be, because that's how they clean ice off the roads. Is it going to be in a tropical rainforest where there's a high constitutive moisture and water and rain? Corrosion is obviously very critical here. It's going to be in a harsh environment where it's a desert, a hot environment where we have UV rays that can damage the product. So if I take that, sometimes selecting the right powder is also about committing to the right layers. And a primer can be a great way to protect your coating for a longer period. Your part for a longer period of time. The reason is because when I'm going through a part, the unfinished part typically has edges. And edges are where the product is most vulnerable in terms of corrosion. It's the most vulnerable in terms of protection. Because when I put my coating on the flat surface, I may be able to put 3 mils. But on the edges, it's not uncommon for that to be 30% of my flat surface. So if I've got 3 mils on the flat, I may only have 1 mil on the edge, and I'm very vulnerable with a one-layer system. Now, this is just an illustration. I selected Goodman off the internet, but look at all of the edges that we have in this part, all the louvers that are necessary for that product to work efficiency. the wire at the top, the louvers at the top, every edge I've got there, there's hundreds of them. Those are very, very vulnerable. And so selecting a product for that may be totally different than selecting a product for something that's just a flat surface. Now, if I've got very sharp edges, it's always best if I can round them. But I'm not naive. I realize that in a manufacturing environment, rounding every edge can virtually be impossible in many cases. But if you can, if you have the time, or if you have the ability to make sure your dies are fresh and sharp and keep those to a minimum, that's going to protect your product better than a very sharp edge. But if you can spray in layers, and if you've never considered layers, come on, man, consider layers. Because if you're not aware of where your part's going to go into, what environment it's going to be exposed to, layers can be a very, very good option for you. And you can do polyester top coat, super durable top coat. You can use a zinc primer. You can use an epoxy primer. You can use a polyester primer. It just gives you the ability to take that particular part that has these sharp edges, put one layer of primer on first. I prefer to gel the primer layer and not totally cure it. And down at the bottom where I've got very limited film build on that edge, then I come back with my top coat and I've just got two barriers of protection that are mono-baked together to give me that. So again, if I'm in the attic in Tulsa, I'm not too worried about it. But if I'm on the beach or in a very high moisture environment, high salt environment, 2-layer can be a really, really good selection to how you want to protect your product. And zinc, the way it works, just so you get an idea of when zinc might be the right selection for you. The zinc is it's a sacrificial anodic properties. And so you want the concentration of zinc to be very high so that you get that anodic property all the way through the coating. A small amount of zinc can just be a waste of time. You have to have a huge amount of zinc. And in my opinion, for powder coatings, you have to have products that are going to be upwards of 3.0 specific gravity or higher. That'll give you typically a zinc content of 60 to 70, even 75%. That's what you need to get that cathodic property. Hanging configuration. So what I'm talking about here, and again, this is one that was selected by everybody that I talked to for this presentation. It's really more about part density. And I'll tell you where this came in. You design a line, you put it in, you're running year one, everything's kind of rocking along. And then year two, you get different parts, maybe of different configuration and sizes, or your productivity goes up, your business is growing. And so what do you typically do? Well, the easiest thing to do is turn the line speed up. Turn that knob and go from 10 to 12 feet a minute or 12 to 14 feet a minute. And I'll tell you that right now, that is your last option. That's the one that you really want to hold off until you've looked at all other ways to improve productivity. The reason is because anytime you speed up that line, your design criteria goes out the window. Now I have less time in my washer, so I'm not cleaning as well as I once did. Dwell time in that washer is how you determine how well you clean. I have less time on my dry off oven. So if I do have areas in my part that may puddle, I'm going to have an issue of getting it completely dry or getting that water off it. I have less time in my oven. So am I going to cure it completely? Am I getting close to the borderline of curing, or am I getting undercured in some of my heavy mass parts? You're asking your applicators and your guns to give you less time to coat. And of course, you got less time to load the parts and unload the parts. So increasing the line speed is not the first answer. And I'll go on to say that I believe it's almost the last answer. Production gains can be more easily done if you look at hanging configuration. So now if your hanging configuration looks like this, come on, man. There's so much. You need to fill that space. You have a silhouette in your washer. You have a silhouette in your powder booth, your dry off oven. We need to fill that silhouette with parts because that's all about productivity. This particular density on the left, if I hung 3 of those as opposed to 1 on every hook, I mean, it's just math. I tripled my production. And on the right, the same principle can apply. This is some pretty good illustrations of good density. My goal is to build a wall. And it's not just about productivity gains. There's a huge impact in terms of transfer efficiency that I'm going to go into as well. But I want very good part density so that I can get my most product and my highest transfer efficiency on my line. And in some cases, you can take the part itself and hang it vertically or hang it horizontally or whatever makes sense for that part. This is a very good illustration. These are aluminum extrusions, and of course, they lend themselves to a very, very good part density. Most of the time, we may not have the luxury of having a part that's long and straight. But you can also take your part and look at it and say, how can I mask the part? In this particular case, I've got a wall of parts coming through. I don't necessarily need a lot of coating on the back. So I'll hang them back to back so that I literally mask the one on the opposite side to a certain degree. The closer together they are, the more of a mask you can get. Part density can be a critical part of how you get more productivity out. Now, one might ask, well, yeah, that's great, but how am I going to hang as fast as I can coat? Spend your money on loading and unloading. If you can improve your part density and you can improve your productivity that way, consider staging how the part. So in this particular case, 1 box would be 1 hook, but I've got 4 boxes hung in a row. And I can stage those to where my loading and staging operation comes in first. And then as I start up my production, those are already staged, ready to be hung, and my loaders are hanging those. And as my unloaders are coming off, I'm staging more parts along the day. So don't be too concerned about loading and unloading. I think there's ways to figure that out, but get optimal part density through that powder coating operation. And I tell you, everybody that I spoke to in the industry agreed with me that this is one of the areas where we could really find the most value to help a customer. And there are companies out there that sell like Mighty Hook and companies like that have different type of hooking arrangements so that you can go out and buy things that might be work great for your particular product, or you can design your own. There's just a lot of ways to do it. You know, one thing that can help your production has nothing to do with your powder operation at all. It really has to do with how you're designing the part. And I say that only just to be cognizant of that. How we're welding that part, how much penetration we need to get in some of those Faraday areas, how we're connecting one metal piece to another metal piece. In this particular case, the vertical bars are welded onto the horizontal bars, and they're just spot welded on there. The problem with that is that if that particular piece of fence goes through my coating operation, I can't clean under that bar and I can't paint under that bar. So I'm going to get corrosion almost immediately. And it has 100% to do with the design of the part. So as we're going through the welding operation, think about that, the design. How are we welding it? Am I spot welding like this so that I really have that area in between those 2 spot welds that I'm going to get very little cleaning, very little powder coverage? And this being cold rolled steel, man, it's going to rust. It'll rust within a week. So sometimes it's not the coating itself. Sometimes it's not the pre-treatment you selected. Absolutely not the process. But how are we designing the part? Is the part being designed good for a coating operation? Different welds, the upper right-hand corner. If I'm putting on 3 mils and my weld's 10 mils tall, I'm gonna get rust there. On the bottom right, I've got 2 metal pieces that are on top of each other, and I've welded them. I haven't even coated it yet, and I'm already getting rust there. So keep in mind, if I'm doing it like this, where I'm actually welding it onto this fence, which is how this one was designed, and this is still, come on, man. I got to rethink that design if I really want to protect that coating. If I really want, protect that particular part. My goal with coating is to make it look better and last longer. That's it. Those two things. I want to make it look better and last longer. Sometimes I just want it to last longer, and very rarely do I just want it to look better. I'm trying to protect that particular product that I put so much money in, and in this particular case has a lot of aesthetic value. So keep that in mind as you walk through it. This is a beautiful weld for a coating operation because I've got complete coverage. It's a very well laid down bead, and I love this particular illustration. So keep that in mind as you go through your steps and your process. Now, if you're powder coating anything, if you have a powder operation, I would recommend, and can assist in you writing a spec. Write a specification. Make it clear what you're trying to accomplish. And it can be 50 pages long and it can be 1 page long. I mean, I'm not asking you to write something that over-engineers what you're doing, but it identifies your intent. And it identifies what you're trying to create so there's no question, and you can go through those steps and measure those periodically. It talks about the scope. What metal are you using? What pretreatment am I going to use? What coating classifications or chemistries am I going to use? Is it thermoset or thermoplastic? Identify your preparation. Is it mechanical? Is it chemical? As I mentioned, you can have a very, very long spec depending on your particular product and what the application is and what environment it's going into. Or you can have a pretty limited spec, but write your specification. Write it because these details can be handed off to shift 2, handed off to a new employee, handed off to any member of your quality control department, handed off to your customer so that they know what you're doing. And if they have any questions about it, there's no doubt this is my intent. When I coat this part, we want it to come out like this. We want it to be defined like this in appearance, in physical characteristics, and film build, and all those elements. And then identify specifications that are out nationally. Powder Coating Institute, American Society for Test Materials, PCI. There's a lot of different companies out there that can, American Architectural Manufacturers Association. So identify those. Don't rewrite specs. ASTM has plenty of specs. ASTM D015 is specific for powder coating, but powder coating utilizes, because it's a coating, many of the liquid coating specified by ASTM. So identify those in terms of, this is what I'm going to use for hardness. This is what I'm going to use for impact. But if there's one thing you have on your spec, and there's only one thing, it needs to be how you evaluate your product. Come on, man. If you haven't come up with a written way to evaluate whether your product meets your quality standards or does not, then it's going to be subjective. And what happens typically when you have a problem, then the magnifying glasses come out. And then everybody wants to look at it under a different set of parameters because they want to get very high level of scrutiny on the new parts coming off. I wrote something here very simple, and you can write it any way you want. But I wrote, and everything underlined can be changed. So I'm going to read it. I've got a powder operation, and this is how I identify, this is how we quality control the parts that are coming off my line. Under incandescent lighting, holding the part at its arm length, approximately 20 inches from the eye, viewing a 12 by 12 inch area for 10 seconds. If I see less than 2 defects of size less than 6 centimeters, it is seen this part is considered a pass. Now you can fill in the blanks. You can change the lighting. You can change the viewing point. You can change the size. You can change the defect number, the size of the defect. Because when you have a problem, you don't want to start looking at the new parts coming off the line differently. Evaluate them the same way every time. And if you're a custom coder, have your customer realize this is how we evaluate it. Do you agree with this evaluation method? Because that will change the whole way that when you have a problem, everybody leaps into action and also tries to kind of move to like a perfect a perfect part. And that's not your intent. Your intent is to make it, well, it could be your intent, but if it is, have it defined. But if it's not, define that. And you think the lighting part under incandescent lighting, you can even put the candle strength as well, which is a very important part. Products will look different under different lighting. You don't want someone looking at it like this and then looking at it like that and then taking it outside and taking it in the office. This is an illustration, and you don't have to have a light booth to define your light source. This is an illustration of two different light sources with the same panel. Obviously, we have metamerism going on here, but this will give you an illustration of how different a coating can look just by using different light sources. So when you do define your quality control evaluation method, please identify your light source as well. It's very critical. Number 7, and this is one that was a little debatable, but most of the team said, look, man, what you have to do, I mean, the powder, we're dealing with powder. It's hydroscopic. It's going to absorb moisture. And so we need to make sure that we are managing our air. And managing the compressed air is only one facet of the powder coating operation. So PSI, pounds per square inch, that's compressed air. LFPM, linear feet per minute, that's velocity of air. CFM, that's cubic feet of air, that's volume of air. And obviously we need to make sure that we are measuring the quality of air. And if you're not doing these things, if you're not looking at these things, come on, man, you need to. Let me tell you why. Velocity of air. You can have a booth that's perfectly designed at 110 linear feet of air movement along all openings. And then you add air conditioning venting or fans on a hot day that have cross drafts on that, and it will change it dramatically. I got final filters that are getting plugged. Change it dramatically. Always look at linear feet per minute. Check it. Mark it. Collect the data. Look at air quality, because the air quality is critical to a powder coating operation. I don't know how many times I've seen a plenum plate on a fluidized bed that looks like this upper right-hand picture where oil has gotten through and it plugs that plenum. Quality of air is critical. It should have a dew point of minus 35 degrees, oil content very, very low, negligible to zero. We've got to take out all particulate matter of greater than 10 micron. And I got to have 100 PSI. I'm not going to run my guns at 100 PSI typically, but I need 100 PSI. I need it for blowdown in my cartridges, if that's my system. I need to have them 100 PSI with the appropriate amount of CFM, volume of air, to my fluidizing membranes and to every other component of my powder operation. This particular one shows that I've got the right PSI, but I don't have enough volume of air. And so I get these geysers, and it doesn't fluidize that particular product or any product because I don't have enough volume of air. And so I'm going to really impact the way that product transfers. So number 7 is, man, make sure that you're looking at all facets of air, whether it's volume, pressure, quality, velocity. All those things are critical to a powder operation. That's the vehicle we use to transfer and apply our powder coating. So air quality is important. Troubleshooting, I could spend a long time on number 8, but I don't have a long time. So I'm going to spend a few minutes on it. And I'm going to tell you why we thought it was really important to add this to the powder coating process. Because typically what happens is when you're troubleshooting, you've got a problem, or you wouldn't be troubleshooting. That's why the word trouble's in the word. So I got trouble. I got a problem. How do I fix it? Well, I think I know the problem. I think I know the solution. So I'm going to start turning knobs. Higher pressure on the guns, higher velocity on my powder booth, changing the KV, whatever the case may be. And what typically can happen is you may get the problem resolved, but you don't know what knob you turn to fix it. So all the other knobs that were unrelated are going to have a domino effect in another area. My recommendation, and I think that if you just take ownership of this, when you have an issue, stop. Just stop. just for a second. I know you're going to think, man, in my production environment, I don't have time to stop. Well, sometimes you don't have time to not stop. Stop and use the SIRE method. Search, identify, recreate, and eliminate. Search. I know I got an issue, but ask those questions that help you identify and break down where the problem may be. Right now, you got to ask yourself, am I that guy that when we have an issue, I just start turning knobs, change many things at once because it's urgent and I got to act urgently? Well, come on, man. Don't do that. Think about the SIRE method. The SIRE method gives you the chance to, by a process of elimination in many cases, start narrowing down where the issue can be. I've just thrown some random questions in here in search. I'm rejecting parts. Well, are all parts rejected? Is there an area on the part that's causing the reject? Maybe it's one area. Maybe it's where they're hung. Is it just the top parts? Is it on all surfaces or just like one surface? Start going through the list of understanding, here's the reject. I know what it is. And now let me start narrowing down where it is on my particular part, our parts. Is the problem outward, meaning it's on top of the part, or is it within the coating? Is it the same on all colors? Do I have a problem just with one color or one particular metal or alloy or one particular part configuration? Ask yourself, when does it occur? Is it just on second shift? Is it just in the morning? Is it when I'm opening the door for deliveries? I mean, is it when I'm running touch-up paint? I look at all of those facets and go, when I'm searching, spend time in this area to really start identifying what's causing it as much as what's not causing it. So when you do that, the I is just you've identified it. I got it. I know where it is. I see it. And now if it's a visible physical reject, defect that's in the coating, start looking into it, magnify it. Man, is it a solid? In this particular case, I'm answering the question. Yep, it's on the back of the coating. Yep, it's a solid. I can see it. And can I separate it? No, it's part of the coating. Just go through the second step. So now that I've identified it and I've searched for it, I know where it is on my product. Now I can start digging into recreating it. So the SIRE is search, identify, and then recreate it, because at this point it's a hypothesis. When I can recreate it based on my hypothesis, then I've proven what I've got going here. And you think that, golly, this may take too long, but at the end of the day, it really does get you to the answer because you want that answer. Finding an issue and troubleshooting is important. Creating a action to where it never happens again, that's the answer. I want to be able to identify it. I want to be able to recreate it. And then once I recreate it, I want to be able to eliminate it by putting in steps and procedures so that it never happens again. And the reason we put this as part of this is because you might think, well, in my powder operation, we have issues and we just kind of run in there and we fix them. Well, you do. And maybe that works. But if you do a systematic approach and you do it every time, you're going to build a library of information so that once it comes up again, you already know the answer. You've already drawn that conclusion because you went through the effort of really narrowing it down and finding out where it was. So that's pretty critical. And then track your rejects. Training. So let me tell you what we typically see in a powder operation for training. This is what we see. And if this is you, come on, man. The new guy learns from the old guy, who learned from the older guy, who learned from the dead guy. Not trying to be crude here, but I mean, every transition between one guy to the next, there's something lost in translation. I'm not going to spend a lot of time on here, but when we're out and talking to people that are applying coatings and powder operations, we'll ask one person, how do you do this? And ask another person, how do you do this? And it is very common to get two different answers, especially when you're cleaning. What are your cleaning methodologies? What are you doing when in terms of cleaning? What technique do you use to spray? Have you defined the cleaning? And do you have a person or persons that are qualified to clean and then a person that evaluates the work after that's done? setting up the washer, startup process, setting on guns, depending on your part configuration, part hanging configuration, oven set points. I'm not going to go into a lot of detail about this, but these are just a short list of the areas that really need to be specific so that one weak link in your process doesn't damage the end product that's coming out the door. You spent the money on the system and you spent the money on setting it up well for your part. Train the people to use the equipment well. We see this very often, and I just want to highlight it for you. The last one I want to talk about is transfer efficiency. And this is another one that I can spend hours on, and of course I won't. But FPTE is first pass transfer efficiency. You hear transfer efficiency talked about in a lot of different ways. TE, transfer efficiency, application efficiency, system efficiency. I focus on first pass transfer efficiency is because that's where it all starts. And I want you to put a conscious effort in looking at making sure you have the highest level of first pass transfer efficiency. And there are many variables. Ground, how you hang the part, is the part stable and racking? If I have a high first pass transfer efficiency, which is along the top, call it 60%, and I have a reclaim efficiency of 92%, I'm collecting 94% of my product. If I have a 25% transfer efficiency and still 92%, I'm throwing away another 15% of that product. It's not just a cost equation. It's about consistency. And I need a very, very high first pass transfer efficiency. Gun setting, gun configuration, lowering output, making sure my product is getting on the part and designed and to face the part in the appropriate way. My lead and lag in terms of automatic guns. My technique in terms of handguns. There are a lot of things that happen when your reclamation process, but one that's not arguable is that as I reclaim, my particle size shifts left because the middle of my particle size range has the highest amount of transfer efficiency. Lower amounts are on fine particles, and we have lower amounts than the middle on even some of the coarser particles. So I want to minimize that bell shift. And the way to do that is to effectively manage the things that impact transfer efficiency. This is kind of an eye chart, but let me tell you the things that will affect the transfer efficiency the most. Gun selection, if the low end is going to be in the blue and the high end is in the red. So gun selection, and there are some that are better and some that are worse than others, and you get some impact there. Gun settings, huge differential. The way I set my guns, the low end blue, the high end's red. The part geometry itself, if I'm spraying wire or if I'm spraying a flat panel, that's going to impact my TE. The technique in which I'm spraying. The powder that I use can impact my transfer efficiency. I can formulate a product for higher transfer efficiency. The downside is if I got a high or higher attraction, if I got a high attraction, I'm going to impact Faraday. So I need to balance that. But the one that's not on there that will impact the most is part configuration and how you hang it. So transfer efficiency is critical, man. I've gone through 10. And there are many, many others. And if you didn't learn anything today, come on, man. Of course you had to learn stuff. But I'm going to turn it back over to Scott. We flew through some of those, but just some good stuff to give you some things to talk about. So, Scott, I'll turn it over to you now. Thank you for your time.
Thanks so much, Steve. We have a few minutes now to open up the webinar for questions. If you have a question, use the Q&A panel in the chat. And as a reminder, the webinar is being recorded and when complete will be made available to you via email from Products Finishing. Let's go ahead and start with some questions. First question, my product can be used in a variety of atmospheric conditions. How do I make sure it lasts in all of them?
Oh, that's a really good question. I talked earlier about making sure you pick the right powder for your product depending on the atmospheric condition. And this particular attendee is saying, "Well, man, I don't know where it's going. How can I make sure it's going to work well in that environment?" If I understood it correctly. Well, I think a most underused way to manage that is by whatever part you're coating, give your consumer, give your customer two options. Let them decide. They know where it's going. This is my standard coating. But if you have an environment that is a harsher environment, a corrosive environment, a exposed to chemicals, whatever the case may be, we have this primer version that gives you a zinc primer and a top coat with super durable technology. And so you give them the option of selecting your standard or selecting this higher version. And of course, you get paid a premium for that. But it does two things for you. It gives your customer the ability to pick the one that best suits them. And you don't over engineer by using this higher cost version everything else. So I'd go with having two options in terms of coating and let the consumer or your marketing team decide which one needs to be sold in which environment. But really, really good question.
Is there a way to check for the powder thickness before it is cured?
Absolutely. As a matter of fact, I think I had an image of one of those, and I should have mentioned it. But there are companies out there that most film gauges are after the product's been cured, is cooled down, and is in a solid form. But there's some out there that before it goes into the ovens, you can get an idea of what that film build will be. There's a calculation, I think, in most of them where you have to enter that into the device itself, depending on the amount of shrinkage that you get in the coating. But there's tools out there, and they really work very, very well. I recommend them if you can put them into your system. Good question.
If a powder is bonded, does it need to be clear coated?
So a bonding application is going to be for metallics, and I would recommend that any metallic is clear coated for two reasons. Number one, even in a bonded environment, you're not going to get 100% bond on the metallic. So if it's in an environment where it's handled a lot or has a lot of traffic on it, it can affect the metallic. That's going to come off first. Absolutely, in blended, you want to clear coat those. I think there's exceptions to that rule where you don't need to clear coat them. Again, where it's not be handled a lot, not going to be handled a lot, maybe in a sealing environment. But depending on where it's going to be used and what it's going to be exposed to, I think clear coating a bonded product can really impact the durability of that over the life of the product.
So this one is, I want to create a written specification, but I'm curious if there's a template I could start with.
Great. Well, number one, thank you. I'm glad that you want to write one. And send me, this is my email address. Send me that request, and I'll be more than happy to send you a template. And as I mentioned, you can expand upon it. You can reduce it, pull out the pieces that are important to you and your process. But I've got a few templates, and I'll be more than happy to share. I think it can be very valuable if you go through that exercise, and I appreciate your interest.
In your experience, what is the number one reason for a powder failure?
Wow, that's a good one too. I think I'd have to say undercured part. Or yeah, I guess probably in my experience that is. Because it's something you can't see. You know, if the part comes out of the oven, it may look good, but you can't tell visually if the part's cured. And you really need to go through a destructive test to determine cure. And so many times we won't do that. We won't go through that exercise. But that's a really good question, because I think cure is critical, obviously, to powder coating. And if we can't see it visually as it comes out of the oven, we need to evaluate it periodically to make sure that our part is meeting or reaching the minimum cross-linking. And then the part mass is going to make that differ. So when I'm evaluating my parts, I want to evaluate the worst case scenario, the biggest mass, because if I'm curing that and I'm not burning the smaller mass, then obviously it'll be cured as well. But I think in my experience, probably cure is probably the one I've seen the most. But good question. I have to give that some thought.
Okay. That seems to be all the questions. Oh, wait, here's one. When using military grade cart coatings, what should I look at for better for better coverage? Appears good pre-cure, but has light areas in the post-cure.
Yeah, I think this principle applies with any coating, not just cart coatings, but opacity is really what the product, you need to understand what that is. So, in the product sometimes can be formulated with high opacity, meaning it's heavily burdened with pigment, or low opacity, meaning that I can see the color, but I'm actually seeing through the coating. There's a test that we use within our lab with contrast ratio panels where we'll spray up that material and it'll tell you when I'm opaque, when I'm completely, um, I can't see through the coating itself. Um, that's where you really got to manage and measure your film build in the dry form and in the cured form. And the product itself won't change. If you're spraying it, it's not going to change, but it is absolutely a measurement of thickness. So getting your handle on the thickness that you're applying it at, knowing what worked. Hey, if that part looked good, knowing what technique you use to get enough in those areas that might be hard to reach or hard to get to, because you need enough film build to get you opacity. Look, it's a good question, and not just related to cart coatings, but any coating for that matter.
What is a minimum cure time in most applications?
Well, there's not one. I can say typical is 10 minutes at 400 degrees. And when they say 10 minutes at 400 degrees, it's not like baking cookies, like throwing them in the oven, 10 minutes at 400. It's the part needs to come to temperature, 400, and be held there for 10 minutes. So if my part mass is significant, it'll take time in the oven to get up to that temperature. And I think that might be some of the reasons why cure is pretty prevalently a problem in powder coating. But you can get down in terms of temperature itself into 250. Believe it or not, 2 and a quarter. 250 is a typical threshold, but you need more time. And let there be no mistake, 250 Fahrenheit, I'm going to lose some physical characteristics and I'm going to need more time in the oven. But I've got products that it can cure even a little bit below that. We're not below that boiling point yet, 212, but some powder coatings are getting really, really low because of heat sensitive surfaces, MDF, assembled parts, things that have sensitivity to heat. And we want to make sure that we don't damage the product while we're curing the part.
Okay. Well, that appears to be all the questions. Steve, thanks so much for this presentation. This has been great, and I'd like to also thank our attendees for taking the time to join us today. We appreciate the time and really hope you'll join us again for the next Products Finishing webinar. For more information, visit pfonline.com/webinars.
Thanks, Scott. Come on, man.